In this video, I'm going to work on an Epson 3D projector. You'll notice that the picture is kind of washed in kind of a greeny yellow here. I'm thinking probably what we've got on this is it could be an optical engine failure. It might be the panel itself, the LCD panels themselves, but it also could be dirt in the light path. So we're going to tear this thing apart and see whether this problem is just caused by dirt in the light path. And we're hoping that that's what the case is in this situation. What quite often happens on these projectors is if you don't clean the filters, heat can build up and can cause damage to the optical engine. So it may be a bad panel or bad blue panel but just from the nature of how it looks, I'm getting good blacks and everything, although the iris closes down on these. They have an auto iris to actually close down as it fades out the black so that you get very good black levels on them. But as you can see, the image has got the two shadows, one at the bottom of the screen here and the other one's up at the top. So that's our problem on this one. I'm going to tear this thing apart and see whether we can get the problem solved. It may just need a deep cleaning of the optical block, and that's what I'm hoping that the problem is going to be, is just a deep cleaning of the optical block. So it's an Epson PowerLight Pro Cinema 6030UB. This is a 3D LCD projector. First and foremost on these units is that you should regularly clean the filters on it. The filter was just cleaned out on this thing recently, but I'm going to take it apart and show you where the filter is so that you can maintain it yourself, because dirty filters is a big cause of failure of liquid crystal display projectors like this. Most units have a filter that you can take out, and this one is no different. There's a little hatch on the front. You just open it up, and here's your filter here. Remove your filter, change it or clean it. Now this one here, we've already blown the dust out of this here. At least I didn't. The fellow that brought it to me blew the dust out. I'm just going to get my compressor and we're going to give this a once over again and make sure that this is good and clean. The next thing I'm going to do is we're going to actually disassemble the projector. So I'm just going to shut it off and let it cool down for a few minutes because the lamp is going to be hot on here, and then we'll work at taking the unit apart. First thing we'll do is we'll just remove the screw for the lamp housing. The lamp cover, I should say. So that just comes off like that. There's one screw. The screw is actually retained in the cover so you won't lose it. So take the lamp cover off to get access. And then there's a bunch of screws that we have to remove on the top and bottom. Of course, remove power. That's always a given. On the bottom we've got screws to take out here. I've actually already removed these screws, and I've removed the screws already around the perimeter. So there's 1, 2, 3, 4, there's 5 screws on the bottom, these 3 screws on the front. I've already removed them, and the screws from the back. So I can take the back cover off, can then remove the front cover. The front cover should just lift off this thing like that. Then there's 2 more screws in the front here that have to come out. That's so that I can remove the top cover. And the top cover will lift off just like that, revealing a large circuit board. Now these 3 connectors here, these are for your LCD panel. The engine is underneath here. So I have to remove the circuit board in order to get at the engine to do any work on it. So the first thing I'm going to do is I'm going to just undo all of the connectors that connect the main board to the external fans and all the inputs and so forth. So we'll just undo all these connectors. These connectors are all keyed. They're only going to go in one place. They're all a specific number of leads. So you don't have to really worry about mixing them up because each one only goes in one specific plug. We'll undo all the plugs. There's also an edge connector here that has to be removed. To remove that one, we're just going to release the little catches on either side like that and unplug it. So now we're going to do the same. We're going to open up the connectors here for the LCD. You just lift the connectors up like that, and then the LCD ribbons will just unplug. And now we can remove the screws and lift the main board out of the way. Looks like there may be another couple more screws I have to take out here because the board appears to be attached to this back bracket, and there's screws here that go in from the bottom, so we have to remove a couple of screws on this bracket, and then the whole bracket should lift up. Then out of the way. One more screw at the back here. One more screw underneath here. Underneath this little black tab, there's one more screw that's hidden. Remove that one. And now we can lift up the main board and swing it out of the way and expose our optical block. Now I'm hoping it's just going to be some buildup of some dust here in the optical block assembly. There's a couple of screws here on top that holds the optical block together. One over here, and one more back here. And then the optical block. Oh, one more screw back here. Then the optical block assembly should lift up. These are our polarizing screens for the light going into the optical block. These are our LCD panels are here. These are the first set of screens that the light passes through first. And what these do is these polarize the light. One polarity, either horizontal or vertical, they polarize the light. And from there, the light passes through the LCD panels, and then it goes into this optical multiplexer where the three colors are combined and sent out the lens. So our three channels, we've got a red panel here, this is the green panel, and this one's the blue panel. As the light enters from the lamp is over here. You get a series of dichroic mirrors. The blue component is reflected from the lamp and it hits this mirror where it goes through the blue panel. The red and green portions of the light, because this is a dichroic mirror, it passes the green spectrum and it reflects blue. So the blue component is reflected towards the blue LCD panel. The remaining colors, the green and the red, continue through this it's called a dichroic filter. It's like a semi-transparent mirror. It reflects the blue and it allows the red and green components to pass. At that point you hit the second mirror, which takes the green component and reflects the green component into the green LCD light, and the red light continues on its way through this lens, through another mirror, through a lens, another mirror, and finally the red component makes it into the red panel. Since what we saw on the screen was a kind of a yellowish cast, that would indicate that if there's any dust blocking the light, it's going to be on the blue panel, which is over here. So that's what I'm going to concentrate. I'm going to take a close look at the polarizing grade here for the blue channel, which is this one here. And I'm going to take a close look at the mirror and the filter and make sure that there's no dust inside here, because that would certainly could cause problems that we are seeing. Try and demonstrate how these panels work. I'm going to point this LCD or this polarizing filter, polarizing grate at my LCD TV. And as you can see right through them. But if I rotate it 90 degrees, it's going to block the light. You see that? Because LCD screens themselves have a polarizing filter on the front. You can see my hand through here, but you don't see the screen in the background. You see that? The screen has disappeared. And if I rotate it back, that's how they work. They work by polarizing light. Upon looking at the polarizing grate, they look fine. So I'm going to concentrate taking a close look to see if there's any dust or dirt on the blue panel itself. So see if I can remove this little lens here. It should just lift out, which it does. The lens itself is clean, so we'll just set that aside. I want to just take a close look and see if I see, oh, I can see some dust on there. I don't know if you guys can see it or not, but I can see some dust. Get that little connector out of the way. Where is it? This one. It's frustrating me, it keeps springing in the way. I can see a bit of dust on this panel. You can see it right there at the top. I think that looks like dust. Let's see if we can wipe that away. It could be a damaged panel too. That's what I'm concerned about. Is this panel here? You can see it. You can see this looks like around the edge of it here. It could be the panel itself could be damaged. I don't see the same image on the other panels that I see on this one. It just looks like dirt. That's what it looks like. Around the edge and up here. I'm gonna get in there with some compressed air and see if I can blow it out. Yeah, it sure looks like a panel failure to me. You can just see that around the edge of it in here. And that would be caused by excessive heat from a dirty filter. And of course the blue is going to get the most of the heat because it's the closest to the lamp. So the mirrors are all clean. See, if I shine my light down here, you can see, if I shine my light down on the mirror, you'll see the light changing color. See the green light here, and the blue light reflects on the other side here of the mirror. See blue light reflecting down here, you see? That's the dichroic mirror. Green light passes here, and then on the other side here, if I shine it down here, you'll see red light on this side. Green here, and red passing through. So here we can give you a clearer example. If I shine my flashlight here, you see the red light shining through here, and green light is onto this side. If I shine through here, you can see it better. Blue light's here, green light's in this area here, and red light passing. That's how the dichroic mirror system separates the light into three colors. Normally the light shines through this direction like that. So you end up with blue, green, and red. But looking at this panel, it looks like this whole optical block is going to have to be changed, which is this whole piece here. It's all replaced as one block. Unfortunately, you can't just change the individual panels because they are aligned with a microscope at the factory, and if you tried to take one panel out, you'd never get your alignment correct. So these blocks are all aligned with a microscope, and they're glued to the block. So I don't think cleaning is going to fix this one, but we'll reassemble it and just see whether I've made any difference at all to it. Ultimately, I think though it's probably going to look exactly the same, and this optical block is going to have to be changed. So I'll have to inform the owner of this and see what they want to do at this point. But we'll put the lens back in. The lens just drops in place like that. And then we can put the circuit board on and reconnect everything, see if it works. Oh, obviously got to put the light guide back together. We know the grading plates are okay because I was able to look at those, and there's nothing on here. There's no dirt on this. So we just put the grading plate back in place, and it just drops on top, and it's held in place with 3 screws. Then we replace the circuit board. So we reassemble all the screws. Don't forget our grounding screws here. So once we get all the screws in place, now it's just time to redo all the connectors. Again, remember the connectors only fit in one spot, so it's pretty easy to figure out where they go. They also have, most of them have got little paint marks on them too, when they were taken out or when they were assembled, to help you identify where they go. Blue paint to blue paint, or blue ink to blue ink, red ink to red ink. And again, most only go into one place. Here's another connector here, it's got blue on it, so it's going to go to that one. There's another one in here, another little 2-pin one, it's got blue on the end here, it's going to go to that one. So it makes it relatively simple to see where all these connectors go. And here's a good rule of thumb. If connectors aren't color coded with paint, before you take it apart, it's a good idea to go through with your Sharpie and just mark them. Put little marks on them yourself so that you know where they go. This may have been done at the factory, or this may have been serviced by somebody in the past and they had to take the board out, so they did that. We have our edge connector to reconnect. Now we have the 3 Zif connectors for the LCD panels, and they just slide all the way in, and then you just lock down the connector. Zif, of course, stands for zero insertion force. These are very, very delicate ribbon connectors here, so you don't want to put any type of undue force on them because they will break very, very easily. Slide in, lock it down. Now I'm ready to reassemble the top cover. Got one wire here that's just out of place. It's going to turn that in so that it faces in like that. Otherwise it's going to protrude into the lamp bay. Wrong type of screw. That's a metal screw that goes down here. 2 types of screws used on these. There's plastic screws and there's metal screws, so you got to make sure that you get the right ones in the right place. Otherwise it's not going to thread. And the front cover goes back on. Like that. Got 3 screws to go on the bottom. Next is the back cover. Back cover just pops on like that. 3 more plastic screws hold the back cover on. And then the remainder of the screws to hold the base on. The back piece is also held on by 3 metal threaded screws. And of course the lamp cover has to go in place before we can turn it on. The lamp cover has its little spring that holds it out, and there's just 1 screw that holds it in place. Now we're ready to plug this thing in and test it again. And of course the unit back together. I knew it was going to be the same because the LCD panel itself is screwed. The blue panel is screwed, you can see it here. Nothing we can do on this. I have to get a hold of the owner of this unit and give them the bad news that they need a new optical block. Again, this is something that was 100% preventable. All they had to do is clean the filter on a regular basis. The guy that brought it to me was insisting that you had to disassemble the whole thing to clean the filter, and that he didn't think that that was something that a customer would be able to do. But as you can see, it's very, very simple to clean the filter on this unit. You just open this little door and lift the filter out. Clean or replace. These filters need to be cleaned every 30 or so hours of operation, because once the filter gets dirty, and I mean, I blew some dirt out of this thing, but before I got it, the fellow that brought it to me was actually one of the installers who picked it up out of his client's house. And he already took it all apart to clean the filter, and he said it was filthy when he cleaned it. The filter's never been cleaned on this thing, and that's a big problem. LCD projectors, the worst thing for the LCD panels is heat. And the only way to keep heat out of the LCD panels is for good airflow. And if the filter gets dirty, you don't have good airflow, it will ruin your projector, as what's happened on this one. Hope you enjoyed this teardown, and we'll catch you in the next one.